Definitely don't want to light this if it's that reactive. Hi guys, welcome back to Expulsion Science. Today we're going to be working with 5 different metals and we're going to be putting them in hydrochloric acid to see how they react. We have zinc, iron, pure carbon, copper, and then we have tin.
Hydrochloric acid is a pretty strong acid. When we pour the hydrochloric acid in with a solution, it'll start to disassociate and the chlorine atom and the hydrogen atom will separate from each other, creating a strong concentration of hydrogen ions, and those will tend to react with a lot of different things, including human skin, which is why we're wearing lab coats, gloves, and goggles today.
Safety first, obviously. Yeah. All right, so we're going to pour 100 milliliters of hydrochloric acid in each of our mason jars. And then we're going to place the metal in them and see how they react.
So it doesn't look like there's a lot of reaction here with the tin. It seems to be roughly solid. It is bubbling a little bit around, but nothing immediate. Looks like the same can be said for our copper. Not a lot of bubbles attached to it at all. It's just kind of sitting there inert. Our square of carbon looks to have some bubbles attached to it, but also not any immediate dissolving.
Our iron seems to be really reacting. Look how much iron is reacting.
There we go.
This could be zinc chloride gas, or it could be hydrogen gas, or it could be water vapor. Definitely don't want to light this if it's that reactive. How did our zinc do?
Well, it's definitely reacting a little bit. I do think the zinc is attaching itself to the chlorine atoms and creating zinc chloride, and in that process, releasing a little bit of hydrogen gas.
And how is our copper doing?
Not a lot. It's mainly just hanging out. It seems like copper is that much of an inert metal.
And then our carbon?
It's reacting a little bit, probably really slowly.
All right, and then our showstoppers. So we have iron.
Yeah, it's definitely melting away.
Yeah.
Creating a lot of hydrogen gas and iron chloride.
We showed it reacting to zinc, and I want to show you guys real quick. We pulled it out a little early, but you saw, now this is all that's left.
That was after about 30 seconds to a minute.
Exactly, almost completely dissolved.
As you guys can see, aside from the copper, we had a slow reaction with the tin, a slow reaction with the carbon, and a quick reaction with the iron, and then a very quick
very fast reaction, almost completely dissolved.
Yeah.
A very quick reaction with the zinc, almost completely gone after 30 seconds. So one of the most common magnetic elements on our planet is iron. And so we have a special experiment for you today. We have an iron mixture. It's called iron oxide, otherwise known as ferrofluid. Now, iron oxide is a little dangerous, which is why today we're gonna be wearing gloves, and we are going to be wearing safety goggles.
Oh yeah.
I'm gonna put some in our petri dish right here.
This is a neodymium magnet. It's very strong. One side has a north pole and the other side has a south pole.
We're gonna go ahead and show you. Ready? 3, 2, 1. Whoa.
So you can kind of see the pieces of iron in the iron oxide sort of aligning themselves in the presence of a very strong magnetic field. As you just saw, the iron in the iron oxide solution was able to suspend itself above the fluid and orient itself in the direction of the magnetic field.
Well, that's all we got for you today. Make sure to follow us for more cool experiments at Expulsion Science.